In this lecture, we will actually start with the vector calculus, and when the calculus term is introduced, you know the differentiation and integration involved. So we will start studying these things, and in combination with vectors means differentiation and integration of vectors. So first, we will start with the introduction of a special operator, and then some new terminology. So you can see there is a operator, this delta this is called delta and defined as I del by del x plus j del by del y plus k by del z, means three partial differential operators are included as a combination. So this is called vector differential operator. And you know, we can put two vectors together as a multiplication in two different ways, one for cross product and one for dot product. And if the quantity is scalar involved, means you have a scalar quantity and a vector quantity, you can multiply them as usual. So with this vector differential operator, we will consider three things. Number one, if phi x y z is some scalar function and we put del phi, then it means I del phi by del x plus j del phi by del y plus k del phi by del z. This is called gradient of phi. Gradient of phi. Second, if v x y z is a vector function, then you know you cannot directly put two vectors together a b. This has no sense. Either you have to put cross product of ab or dot product of ab. So keeping the sense of vectors, we can, because v is a product and del is a product, v is a vector and del is a vector, so you can either write del dot v or you can write del cross v. So del dot v as the scalar product, we have already revised in the previous lecture. So and you also know the dot product. So this will be del by del x, and if b is some vector, so it must have some components. So let components be vx I plus vy j plus vz k. So v has these components and del has these components. So dot product will take place del by del x bx plus del by del y vy plus del by del z vz. You know dot product, so this is the dot product of two vectors, so del and v, and this has a special name. This is called divergence. Divergence of vector v. And as a third part, if we consider del cross v, del cross v, so because del has these components, v has these components, and we have discussed and you also know in advance what is the cross product. So we will write it as I j k, then components of del by del x, del by del y, and del by del z, then components of v. So vx, vy, and vz. This again has a special name. This is called curl of v. So we have three different things. First, gradient of a scalar function. Second, divergence of a vector function. And third, curl of a vector function. So we will study these three things in sequence gradually. So first we will be starting with the study of gradient of a scalar function phi. So before doing some questions of gradient, we will understand a little more about the gradient. So gradient, del is the vector differential operator, you know it, and phi x, y, z is some scalar function. Some scalar function. This is vector differential operator. So just we discussed that del phi is gradient. So what is gradient? Gradient of phi. So first what we discussed is del phi is called gradient of phi, and because del phi is equal to I del by del x phi plus j del by del y phi plus k del by del z phi. So we will have a little more understanding about this. So let phi x y z is equal to c denotes some surface. Suppose this is some surface, phi is equal to c, and there is a point x y z, and its vector position vector is r. So take another neighboring point with the position vector r plus delta r. So this point will be delta r. If it is p, it is q, then pq vector will be delta r. So if we have discussed in the previous lecture that in limiting position del dr will be the tangent to this surface. So let r is equal to xi plus yj plus zk be position vector of a point xyz on this surface, then dr is tangent to this surface, and consider the dot product del phi dot dr. So we know del phi is this, so I del phi by del x plus j del phi by del y plus k del phi by del z. And in previous lecture we discussed that this dr is I dx plus j dy plus k dz. So when dot product takes place, you will get del phi dot dr is equal to del phi by del x dx plus del phi by del y dy plus del phi by del z dz. And we have already studied the total derivative. So total derivative, in that sense, this will become d phi, but phi is equal to c, so d phi is equal to 0, therefore this is 0, and this implies del phi is perpendicular to dr. But what is dr? Dr is tangent vector. This implies del phi is normal to this surface. Phi xyz is equal to c. So whenever we have a surface of the type phi xyz is equal to some constant or some or 0, then del phi will become the surface normal, outer drawn normal at each point xyz. So this is the one thing that you must understand about the gradient. So gradient of phi is normal to the surface. We must know some more names that are used and that have been inferred for the gradients. So number one, del phi is normal to the surface. Phi is equal to c. We have just discussed it. Number two, del phi is magnitude of del phi is maximum rate of change. Maximum rate of change of phi xyz. Number three, del phi is called directional derivative. Directional derivative We sometimes refer it to as DD, directional derivative of a function phi x y z. If phi x y z is some function, then del phi is referred to as its directional derivative. So del phi is gradient of phi, del phi is normal to the surface, phi is equal to c. Mod of del phi is maximum rate of change of phi, means maximum rate of change of a function or a surface. And del phi, if phi is a function, then del phi is called directional derivative. So these are the terminology that you must remember. And finally, if you have to find out the surface normal, just we have already discussed here. So let phi x y z is equal to c be some surface. Then if you denote by n the surface normal, then surface normal will be this phi. And if we sometimes we need to find unit surface normal, so unit surface normal, this will become del phi by magnitude of del phi. So these are very useful things that you must remember before going ahead. Now let us take some examples. So example 1, find grade 5 at at 1 2 minus 1 1 minus 2 minus 1 if phi is given by 3x square y minus y cube z square. So as we have learned the formula, del phi is called grade phi, and this is I phi x plus j, phi y plus k. Phi z means partial derivatives. Phi x, phi y, phi z are partial derivatives. So we get I, then partial derivative of phi with respect to x. This is 6xy plus j times phi y will become 3x square minus 3y square z square plus k times phi z. Phi z is just minus 2y cube z. So this is the del phi, and the question requires you to find the value of del phi at 1 minus 2 minus 1. So just the values of x, y, z, x is equal to 1, y is equal to minus 2, and z is equal to minus 1 in this grade phi that we have calculated, and you will get minus 12i minus 9j minus 16k. And as another example, so this is example 1, and we take it as example 2. So show that if u is equal to x plus y plus z, v is equal to x square plus y square plus z square, and w is equal to xy plus yz plus zx, grade u, grade v, and grade w are coplanar. So you know that for three vectors to be coplanar, the scalar triple product must be 0. So first we find the gradient. So gradient of u is equal to I plus j plus k. Remember the definition. Gradient of v is equal to 2 times xi plus yj plus zk, and gradient of w is equal to y plus z I plus x plus z j plus x plus y k. So this is the gradients, and to show that these gradients are coplanar, we must find the scalar triple product. So scalar triple product del u, del v, and del w This is shown by the determinant of the components of these vectors. So first component of u is 1, 1 and 1. Component of v is 2x, 2y, 2z, and component of w is y plus z, x plus z, and x plus y. So you can open the determinant and this will become 0, and therefore we confer that del u, del v, del w are coplanar. And next example, example 3, find the angle between the surfaces, find the angle between the surfaces x square plus y square plus z square is equal to 9. This is a sphere, and z is equal to x square plus y square minus 3. So first we should take the functions, these functions as phi1, phi2. So let phi1 is equal to x square plus y square plus z square is equal to 9, and phi2 is equal to z minus x square minus y square is equal to minus 3. So in order to find the angle between these surfaces at a point xyz, we must find the angle between the tangents at a point or between the normals at a point. Angle between the surfaces will be same as the angles between their tangents and angles between their normals. So we know the formula for normal. Grade phi is normal to phi. So we will find gradients means normals. Let n1 and n2 be surface normals to phi1 is equal to 9 and phi2 is equal to minus 3 respectively. Then find phi 1, phi 2. What is phi 1? N1, N1, what is N1? N1 is equal to grade phi 1. And this is 2xi plus yj plus zk. Then find its magnitude as well. And then N2. N2 is equal to del phi 2. This is equal to minus 2xi minus 2y j plus k. So these are n1 and n2. Now in order to find the angle between them, let theta be the angle between surfaces at a point x, y, z. Then n1 dot n2 is equal to n1 n2 cos theta, and you know n1 n2 n1 vectors n2 vectors, so these n1 and n2 are just the magnitude, or you can also write them as this n1 and n2, this cos theta. So in order to these you can write, so first calculate n1 dot n2 and n magnitudes of n1 and n2, then so n1 dot n2, this is 2 times xi plus yj plus zk dot 2x minus 2xi minus 2yj plus k. So the dot product becomes 2 times minus 2x square minus 2y square plus z. This is the dot product. And what is n1 n2? So n1 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 means magnitude of n1, so this will be square root of this, so 2 times x square plus y square plus z square, and n2 is square root of 4x square plus 4y square plus 1. So just put these things and you will find theta is equal to cos inverse n1 dot n2 divided by n1 n2. Now for an example, take this theta as a particular point. So for example, find the angle at xyz is equal to xyz is equal to 110. Suppose we take 110, then what theta comes out to be? Theta is equal to, so this n1 dot into 110, so this will become 2 into cos inverse this, 2 into minus 2 plus 0 and divided by n1 into, so 2 square root of 1 plus 1 into square root of 4 plus 4. So you can calculate this. This is cos inverse of minus 8 and that divided by 2 root 2 into this is actually 8, so 2 root 2, 2 root 2 into 2 root 2, so 4 into 2 8. This will become cos inverse minus 1, and cos inverse minus 1 means minus 3 pi by 2, sorry, cos inverse minus 1 means pi, so this is pi, so this is the angle. So this may be surprising to you how the angle is pi, but this is a pseudo angle because the sphere does not lie. Actually, if it is hollow sphere and you consider its surface, then it does not lie at the point 110. But their tangents intersect at this point at a particular angle. So this is a pseudo angle between these two surfaces. Next example, find the component of grade phi in the direction of the line x plus 10 by 2 is equal to y minus 5 by minus 2 is equal to z by 1. If phi is given by 5x square y minus 5y square z plus 5 by 2 z square x. So we have to find first we have to find this gradient of phi, then the component of gradient in a direction, and what direction is that? Means along the vector parallel to the given line. So first find, so we have already discussed in the previous lecture, introduction to vector calculus, that the line parallel to vector parallel to this line is given by line vector parallel to given line is r is equal to 2I minus 2j plus k, and the unit vector along this vector will be, and unit vector means direction vector, this is sorry, this is r vector by r. So this you can find its magnitude is 4 plus 4 plus 1, so square root of 9 is 3, so this is 1 by 3 2I minus 2j plus k. This is the unit direction vector. So we need to find the gradient of phi along this one. So now find the gradient of phi. So gradient of phi is what? Gradient of phi. So I times this 10xy, and find the gradient at some particular point, at a point 1 1 1. We will find the component of gradient in direction of this line at this particular point. So this phi is equal to I tan xy plus 5 by 2 z square plus j 5x square minus 10 yz plus k 5zx minus 5y square. So this is the gradient, and at 111 means this gradient at 111, this will become 25 by 2 I minus 5j. Now we find the component of this in the direction of r cap. So component of del phi at 111 in the direction of r cap, this is equal to del phi 111 dot r cap. So del phi is this, and we have calculated r cap, so you can write down this is 25 by 2 I minus 5j. And what was this? So this was 2 by 3 r cap of 2 by 3 I minus 2 by 3 j plus 1 by 3 k. So because first vector has no k component, so take the dot product and you will get this as 35 by 3, means 25 by 3 plus 10 by 3 is equal to 35 by 3. And take a final question of gradient. Example: if vector r is given as xi plus yj plus zk, find gradient of r to the power n. Mind that this r to the power n, this r is magnitude of vector r. So we will find this, and we will use some formula that we remembered in the first lecture. So del r, actually what is, first write down what is this r. So r is given as vector r. This r is given as square root of x square plus y square plus z square, and in turn you can write r square is equal to x square plus y square plus z square. And now what is del r to the power n? This is I del by del x r to the power n plus j del by del y r to the power n plus k del by del z r to the power n. So let us start computing any one of them. So what is del by del x del r to the power n? Del by del x r to the power n. So this will be n r n minus 1 del r by del x. And in previous lecture I told you to remember this formula. When r square is this, so del r by del x is x by r. So this is n r n minus 1 x by r, and I am repeating this, del r by del x is x by r, and del r is del y is y by r, and del r by del z is z by r. So you should remember this always, and thus we got this as n r to the power n minus 2 x. So this is del by del x Rn. Similarly, del by del y Rn, you will get n r n minus 2y, and del by del z Rn, you will get n r n minus 2z. So combine all these, so we get del Rn, this is equal to these components. So you can take n r n minus 2 common, and then the remaining x I plus yj plus zk, means we substitute all the values here, and that is simply n r, n minus 2, and r vectors. We will again use this formula also in some next questions. Dear students, initially I prepared this lecture complete including divergence and gradient, but the lecture became very long, so I had to trim this and I had to stop at this point. So the topic of gradient has been completed here, and the next topic, the divergence of a vector field, will be introduced in next lecture. So stay connected and wait for the new lecture to be uploaded on YouTube for divergence of a vector field.